thanks for joining the webinar. I'm going to take a few minutes, actually about 40, to go through this presentation. This presentation essentially revolves around the course that we published through Pluralsight called Understanding the Difference Between Microsoft Azure and Amazon AWS. So for those of you that don't know me, I'm actually going to let's go through the bio real quick. A quick disclaimer, I am a Microsoft MVP, so I am not going to be biased in any way, shape, or form towards Azure during this presentation or even in the course. This is an agnostic approach at pretty much giving you all the necessary information that you need in order to make more informed decisions when you're choosing the cloud platform of choice. I'm currently the CTO for a consulting organization, Sigma Solutions. I've also been in IT for over 16 years. I've done a lot of training, a lot of speaking, vExpert, CTP, and MVP as well. I've written several books and several DVDs with Train Signal and Pluralsight and so on, so I figured I'd share those as well. Agenda at a glance, and this is the same agenda that you would see on the course as well. We're going to talk about a lot of things. I'm going to try to, again, some of these are going to be a teaser for the course just because the time allotted for this is not going to allow to go into as much details. But I'm going to try to cover as much as possible and give you as much as possible, and feel free to ask any questions you want. We're going to start off with why the public cloud. There's a lot of confusion as far as why to use the public cloud, should you use the public cloud. We're going to cover some of that, see what's the marketing fluff there, what's reality. We're going to talk about how to get started. So if you're trying to embark on this public cloud journey, how do you get started? Do you just go out and get a subscription? Are there any free tiers? We're going to talk about some of those as well. We're going to talk about some of the features. So the important thing to know when you're trying to make a decision about whether to go with Azure or AWS or any cloud provider for that matter is to understand the different features that they offer you and whether or not these features are going to cater to your requirements, your application requirements, or your environment requirements. We're going to talk about cost. Cost is probably one of the things that you're most interested in when it comes to public cloud. Are you really going to save money? We're going to spend some time on that. We're also going to talk about operations. Operations is another very important thing. How do I monitor? How do I manage? How do I keep my billing under control? All of that is also important. How do I manage SLAs? How do I understand SLAs? Security, probably one of the Achilles heels for entering the public cloud. At least that's the notion that's going around is maybe public cloud aren't as secure, so we're going to discuss that and see if that's actually true. Then we're going to talk about hybrid cloud. So while everybody is trying to look at the public cloud, I think everything is going to settle at some point at a hybrid cloud mix where you have some workloads in the public cloud, others in the private cloud. So which one of those providers are going to offer you the integration capabilities with on-premises? And then also as part of the course, we're going to talk a little bit about desktop as a service, and I'm going to touch on that very, very lightly. Now, some of you are probably going to ask, well, why desktop as a service as opposed to DR as a service or others? This is just a topic that all of the larger cloud providers today are offering, so it gives me a comparison point of being able to show you something. Now, before I get into starting to talk about why public cloud and some of this other stuff, I just want to set some expectations. Whenever we talk about cloud, everyone is approaching cloud from their perspective. Cloud is a very large term. It could mean a lot of different things to a lot of different people. So if you're a developer, it could mean something for you. If you're an IT admin or architect, it could mean something else. If you're a business person, it could mean something completely different. So depending on where you're coming from, the information that I'm going to present is either going to be very relevant or it's going to be somewhat relevant. Some of you are going to be looking for more stuff. It's very difficult to kind of satisfy everyone's requests when it comes to cloud in particular. So I wanted to set that expectation before we kind of jumped into things. So with that, let's talk a little bit about pain points and inhibitors when it comes to the public cloud. So one of the things that you're immediately going to start asking yourself is, how do I do integration with the public cloud, right? If I want to leverage that infrastructure as a service, whether it's for bursting capabilities, whether I want to put some workloads there, how do I do that integration? What does that look like? How do I do a direct connect? Can I connect to my MPLS network? Do I do a site-to-site VPN? Am I connecting strictly over the internet? What do I do there? What do I do with sizing? How do I figure out sizing when it comes to the public cloud? Now keep in mind, the public cloud is infrastructure that you didn't build. You're working, or you need to understand someone else's infrastructure. The thing with private clouds and on-premises data centers is we've been doing this for the last 20 or 30 years. We've mastered the art of building data centers. It's our infrastructure. We know exactly how to build it. We know exactly how to size it. When you're starting to deal with public clouds, you need to understand what someone else's infrastructure now looks like in order to properly size your workloads to function properly against that infrastructure. So the sizing exercise, you need to have an open mind. You need to learn to understand how that infrastructure was built before you can do sizing. If you're going to try to go into the public cloud with the notion that I've been doing this for the last 30 years, I know how to configure a virtual machine, you'll find that you'll fail miserably at it. You need to understand all the components that are creating that infrastructure in order to size it effectively. And that leads into cost savings. If you know how to size it properly, then the cost savings are either going to be there, they're either going to make sense, or they're not going to make sense. The other thing that is a pain point or an inhibitor is cost per hour. Is cost per hour really the driving factor that you should be looking for when you're considering the public cloud? Is that the only consideration that you should be taking into account when you're considering the public cloud? Those are all things that we definitely want to talk about. Then you get into partner models. Well, I like the public cloud. Everything looks good. What types of partner models do I need to have with Amazon or with Microsoft? Which ones make more sense because they'll have several? What features do I really need? And do I have these features from both Amazon and Azure? Again, you're going to find that cost per hour is not going to be necessarily the driving factor for the decision-making process of whether to go with Amazon or Microsoft or anyone else for that matter. It's going to be the business requirements. It's going to be those features that are needed to make your project successful. And then, of course, security. We need to understand security. Security can either be an Achilles heel, and it could be a catastrophe, or it could be something that works to your advantage. So when someone says the public cloud is not secure, I will actually say the public cloud is probably more secure than most of our on-premises data center. The equipment that they're using, the talent that they have there, the process, the standardization, the discipline that they have is a lot more streamlined than you would find in most on-premises data center. However, I've also seen, and I'm sure you've heard reports and you've read articles about companies that have gone bankrupt leveraging the public cloud when putting their workloads out there because they didn't secure it properly. And I'll give you a very quick example there. There was a company out of New York, I think this was 6 or 7 months ago, that was dealing with security backups. So they were doing backups for their customers. And they were using it on Amazon. So what they were using is the root password to log in. One of their consultants or somebody hacked that root password and was able to essentially hold them hostage, either pay me this much money or I'm going to wipe out your entire data. They didn't pay, obviously. They wiped out the data, and the company ended up declaring bankruptcy. Now, how would you have gotten around that? Well, did you use multi-factor authentication? No. Well, okay, that's on you. That's not the public cloud not being secure. That's you, again, not understanding the infrastructure, understanding the capabilities and tool sets that are available to you in order to secure your environment. We can also talk a lot about security. If you read about most of the breaches that have happened with Target and Visa and PayPal in the past and all those, most of those you'll find that they were on-premises breaches and not necessarily public cloud breaches. This is not to say that I'm saying the public cloud is secure and you should go all out and put everything there, but I'm trying to make the case that it's not as bad as what you're hearing or what you're seeing out there. There are also licensing implications that you should be aware of, whether it's operating system licensing, application licensing, what you need to bring as opposed to what the provider will give you. All of those have to be taken into account. Scripting and automation is what will make or break a public cloud deployment. You have to understand, again, the capabilities from a scripting and automation. If you're a developer, what are the tools that are available to you in order for you to make some of this happen? Redundancy is also another inhibitor or pain point. How do I make things redundant? How do I make sure that my systems are always up and running? So why public cloud? Let's go ahead, and I'm going to try to go through this a little quick. So cost savings. This is one of the first things that you'll hear. Cost savings, OpEx versus CapEx. You've heard that a million times. They're trying to make the case that there's no CapEx expenditure. You're going to have a lower total cost of ownership. You're only paying for usage. You're avoiding over-provisioning and overcapacity. One of the things that we've mastered really well with on-premises or with our own data center is we tend to over-provision. We do the math and we end up with, well, we need 5 terabytes of storage. You'll find that when you go to purchase, you're purchasing 10 terabytes of storage because you're over-provisioning that capacity. So all of these are things that are advertised as things that you can save if you use the public cloud. Scalability, you have the ability to have rapid elasticity, rapid expansion, whether it's local within your geography, within your country, or global. You have the ability of doing disaster recovery a lot more seamlessly and a lot cheaper. Disaster recovery is one of those checks that organizations typically don't like to pay. It's an insurance policy for something that may or may not happen. Can you really leverage the public cloud to save money there? You have, again, flexibility. You have the ability to change hardware on a whim, essentially, or if not on a whim, at least on a reboot. You can turn off that virtual machine, swap out the hardware, power it back on, and voila, you're up and running. You have the ability of applying a lot of the standards that you have on premises onto that public cloud, so you can bring those baselines in as well. Training, it's a great way for training. You can bring up these labs that you can test your applications against. If you're a developer, you can test your applications against that. So it provides that playground, again, that temporary playground where you don't have to have dedicated hardware for it. You can always try a new thing. So is all of this marketing fluff? Well, my answer is not really. Not if it's done properly. So if you take the correct approach at the public cloud, you'll find that most of this is not actually marketing fluff. You can actually accomplish a lot of these savings and gain a lot of these benefits. Now, when we talk about cloud service providers, and here I want to show you, and I'm not really supposed to show magic quadrants, but I'm going to try to get away with it. I'm known for breaking a few rules. But this shows you, again, what was going on in 2010, according to Gartner. And you'll see that in 2010, everybody and their grandma was essentially on this magic quadrant. Everybody was a cloud service provider. And my opinion is the reason for that is there wasn't enough criteria established for what is a cloud service provider or what to expect from a cloud service provider. So everyone that had a colo or a hosting next to their name essentially just replaced that with cloud, and voila, I'm now a cloud provider. As you start to get into 2012, you'll see that that list starts to kind of shrink a little bit, and you're starting to get a better view of what's going on there. You'll also see that in 2010, Amazon was barely on the right on the list. In 2012, you'll see that they moved into that upper right leaders quadrant. In both of these cases, you'll find that Microsoft didn't even make the list. They didn't even show up at this point. Here's what happens in 2013, and I find this really interesting. For the first time, Microsoft showed up to the right. They're still not in the leaders quadrant, but to the right. In 2014, voila, they've shot up into the top right, and you'll see that this list has kind of cleaned up, right? A lot of these service providers have fallen down and to the left, right? So everybody's kind of exiting this list as the criteria for cloud service providers has been properly established. The point that I want you to take away from here is not everybody's able to invest enough in order to get to the scale that is required, in order to get to the automation and interconnected infrastructure that's needed to be a true cloud provider. The idea here is that Microsoft and Amazon are truly spending, and you're going to see that others are going to make this quadrant soon. IBM, VMware, and Google, and others will probably make this, and some of the existing players are starting to spend. But the idea here is how much money Microsoft has really spent on Azure to bring it up to speed. So a lot of people will ask, well, the cloud, we're hearing everything about cloud, but is it really that popular? Well, no. 98% of workloads or virtual machines are still running on premises as of 2009, right? The VMs in the public cloud back then were 2%. You'll see that in 2014, it's 94% on premises with a 6% in the public cloud. So that shift was very slow between 2009 and 2014. And one of the things that I tell my customers is that the cloud will arrive in bits and pieces, not in one large chunk, not in one large migration. And what I mean by that is you have already started to see things that have gone to the cloud without even you noticing them, right? Exchange, Microsoft Exchange is one that really stands out. Most organizations are either going to Office 365 or have gone to Office 365 or are mentally prepared to go to Office 365. That's a workload that essentially has been lost completely to the cloud. And you'll find that there's a lot of other workloads that are similar that have just gone unnoticed, slowly have gone to the cloud. So the cloud's never going to come as an entire migration. We're just going to migrate everything. It's going to come in bits and pieces. It's going to trickle in. You'll see things like Salesforce, like Office 365, and others that are already in the environment. So you'll see that the cloud's already here, and it's already taking market share. And that 6% that we have today, I believe that moving forward, you're going to see significant increases, and it's not going to be 1 or 2% moves when it comes to the public cloud. Now, another quote that I could give you, I'm fond of quotes today. Today we say we justify a physical server. Tomorrow we're actually going to start saying justify putting it in the private cloud. So in the next 5 to 10 years, I believe that the public cloud is going to host most of our workloads, and then you're just going to have your most precious, your most important things in the private cloud. So you're going to have to say justify putting something in the private cloud as opposed to putting it in the public cloud as the prices continue to fall as well. So with that, let's talk about a few things that you need to know about the public cloud. Well, first of all, understanding cloud infrastructure, right? So not every cloud service provider can say, I'm a cloud service provider. Some of the questions that you have to be asking is, do you have an interconnected infrastructure? Do you have scale? What types of geographies do you cover when it comes to infrastructure? Is it just within a particular region? Do you cover parts of the U.S.? Do you cover all of the U.S.? Do you cover Europe and Australia and Asia? Do you need to have a scalable infrastructure in order to be considered a cloud service provider? And you need to have an interconnected infrastructure. That interconnected infrastructure has to have components like billing and reporting and automation and self-service. All of the things that we come to expect of a cloud service provider have to be built in before I can consider this to be again, a cloud service provider. If someone just has one particular location and they're saying, well, I have a cloud, well, how do you justify cloud? And we're going to talk about some of the differences between these cloud service providers because I think they all have a role to play, but it's important as you're starting to evaluate your cloud service providers, the ones that you want to go with, to understand their scale, their capabilities, their billing, their reporting, their monitoring, a lot of the tools that they're going to enable you with in order to monitor that infrastructure, your workloads on their infrastructure, and to automate a lot of the things that you're putting on there as well. So with that, let's talk a little bit about what we've been doing and what's going on. So for the last, again, 20 or 30 years, we've been in build and operate mode, which means we build the data center, we operate the data center, we monitor the data center, we install the operating system and the applications and the hypervisor. Everything that we've done, right, is build and operate. You'll find that today you're moving more and more towards a broker of services type model. You're no longer necessarily just building and operating, but you're also facilitating your business requirements for access to certain SaaS or platform as a service or even infrastructure as a service requirements. A good example of that is what we just talked about, which is Exchange and Office 365. That's something that you are now brokering on behalf of your users, right? You're no longer building an Exchange and installing Exchange and managing and monitoring it. You're simply brokering that service with some level of administration that you're doing as far as that is concerned. Salesforce is another one. You're brokering that service to your users. But there could be other services that maybe your users are coming to you and saying, I need you to go investigate this and figure out what are the requirements and just bring it and offer it to me. A good example would be Dropbox. Dropbox is one of those services that has also creeped up on most enterprises that now IT is having to deal with. You're having to go through and bring that particular service under IT control again to some extent. So you're brokering that to your users. So as part of brokering, your job is going to be the negotiation of contracts. You're going to be responsible for making sure that you're enforcing SLAs so that the service levels are there, dealing with outages. All of the stuff that you would deal with from a build and operate on your own infrastructure, you're now having to broker to your users in addition to a lot of the build and operate that you're doing from a private cloud or a data center as well. So we talked about cloud service providers and classification, and I told you that, well, not everybody could be a true cloud service provider. And while you have some cloud service providers, you have the hyperscale cloud service providers, those like the Amazons and the Azures of the world that have that hyperscale, that have that international presence with interconnected infrastructures, with the proper automation and orchestration that goes into it. And you're going to have those, and those are going to be more general purpose infrastructures where you can leverage them to put your workloads on there, configure your workloads manually. You have a lot more control over some of these hyperscale. Whereas from a cloud service provider's perspective, you'll find that you're going to go to these cloud service providers when you need more value-added services. So maybe one or two or other cloud service providers will be able to give you maybe better services if you want to put your e-commerce application there. They'll be able to give you better application support, better technical support, help desk support. So maybe it's more appropriate to go there. Maybe some other workload is also more appropriate to go in that cloud service provider quadrant because they're specialized in it
from a healthcare perspective maybe, or from a financial perspective. And then you have your private cloud. The idea that we need to get to is that we're going to use all of these at some point. But how do I move my workloads seamlessly, or how do I interconnect all of these so that I can, on a switch, on a whim, either move my workloads or at least have connectivity between them so that I'm getting the best performance, the best scale that I can offer back to my users. That's the mindset that you should be putting forth or setting forth. Now, when we start to talk about hybrid clouds are also not easy. A lot of people will think, well, I already have a VMware or a Microsoft presence on premises. How do I do hybrid cloud? That should be easy, right? I just establish a site-to-site VPN, bada bing, bada boom, I'm up and running. Well, there's a lot of things that go into play: access, availability, performance, governance, protection, security. All of those have to be kind of spelled out properly between the different cloud service providers. This criteria has to be established, the processes, all of that has to be put in place before you can have that happen in a more seamless way. So hybrid clouds are not easy to do. They're not impossible to do. They're absolutely possible to do, but they're just not as easy to do as some would expect. Let's also talk a little bit about how we do things on premises and how the public cloud does things. So on premises, we're used to scaling up for the most part, whereas in the public cloud, it's all about scaling out. It's all about smaller instances, smaller servers that you're scaling out as opposed to scaling up. On premises, we're also assuming reliable infrastructure, whereas in the public cloud, you should expect infrastructures to fail. And the reason for that is on premises, again, we are the ones that are building that infrastructure. We're putting all of the redundancies, all of the capabilities, we're putting all of that into our infrastructure, what we're building. The public cloud is an infrastructure that was built to cater to different workloads. As a result, you should always build with the mentality of expecting a failure, and expecting a failure means you have to work around it so that you provide higher availability. So let's dig a little deeper into that. For the most part, when we're dealing with on-premises infrastructure, when we're assuming a reliable infrastructure, that's because we're doing that at the hardware level, whether it's storage or networking or servers. We're putting all these redundant components in there. We're having redundant LUNs and redundant network paths, etc. But we're also taking advantage of a lot of the operating system features, whether it's fault tolerance or clustering or load balancing. Most of the features are available at the operating system level. We have some features that are also available at the database level, whether it's SQL or Oracle or others, that provide that high availability. But for the most part, the application that's being installed on our infrastructure, on our on-premises infrastructure, the application is expecting a reliable infrastructure. And we're offering that reliable infrastructure by leveraging the operating system and the database high availability capabilities. When you're working with public cloud, and depending on the type of workload, the idea behind the public cloud is that the design of the application is completely different. It's more of a service-oriented architecture, SOA, as opposed to a client-server architecture. Now, that doesn't mean that in the public cloud we can't use a client-server infrastructure and still provide a lot of those capabilities that I just talked about, but we're still leveraging the same types of stuff, right? It's still operating system clustering, load balancing, and database, HA, etc. Whereas when you start to develop applications that are specific to take advantage of the public cloud, what you're doing there is the application is now becoming aware of the infrastructure, which is why the application can then compensate if there's an infrastructure failure or if it needs more load. So for instance, if the application requires more database services, it can make those API calls and request more database services. If it needs more front-end web servers, it can make those requests. So the application becomes in control of the infrastructure as opposed to what we have today where the application is not aware of the infrastructure and the application is relying on us, on IT, to make sure we're presenting it with reliable infrastructure. That's not to say, again, that we can't leverage client-server workloads in the public cloud, but we still have to take advantage of a lot of the same things that we've been doing for a while, which is why I'm saying we have to properly understand the public cloud infrastructure and the capabilities so that we can properly build environments for it. On premises, we had fixed costs. We knew exactly how much something was going to cost. This is going to cost $1. I pay for it and move forward, right? In the public cloud, it's more usage-based. Again, in on-premises, we're traditional management. You're managing, every one user is managing up to 100 servers, for instance. In the public cloud, everything is automated. Nothing is left for manual management, and as a result, each user can probably manage up to thousands of objects in the public cloud. When designing for the cloud, again, I stress this, assume unreliable infrastructure. And this presents itself in a really good way when you take a look at what happened with Netflix a few years ago. Netflix, for those of you that don't know, for the most part runs on Amazon AWS. When Amazon or parts of Amazon failed a few years ago, Netflix, all that happened to them is they saw an increase in load on the remaining silos that didn't fail, which means their application was very well designed to take into account an unreliable infrastructure or infrastructure that could fail. And the same thing should apply when you're designing in the public cloud. And even if it's a client-server environment, and I'll give you a quick example that we'll touch on a little bit later. If you're trying to put all of your workloads in one availability zone on Amazon and that availability zone fails, well, it's on you. You didn't understand the infrastructure and how it was built, and the fact that you need to put your workloads across 2 availability zones or across 2 regions, for instance, and build your clusters across those availability zones so that if one fails, you can continue to operate your application without a hiccup or without significant outages. So again, understanding the infrastructure and designing for unreliable infrastructure will always lead to success. Number 2 is understanding cost. When it comes to cost, there's a lot of things that go into dealing with it, right? So you have to understand your discount bands. What levels of discount am I going to get with Amazon if I use this particular band as opposed to that? If I'm using Amazon Azure, do I leverage my enterprise agreement? What am I getting with MSDN? What am I getting for free? How does all of that play out before I can put my workload there and figure out if it's going to save me money or if it's going to cost me money? Design implications. This is critical here. On premises, we've always been used to the idea of we're just going to build a server, we're going to build the virtual machines, and we're just going to power them on and they're going to run forever. The reason for that is on premises, we don't really know how much things cost. Now, I can ask that question, and a lot of you will say, well, I know exactly how much something costs in my environment. The reality is we don't really take all of the factors into account. So while we have an idea of how much something can cost, we don't really know exactly how much it costs. And as a result, we just take things for granted. We're just going to power that virtual machine or that server on and keep it powered on all the time. Once it's powered on, it's essentially never going off unless it's for maintenance or hardware failures, etc. If you take that same design principle and apply it in the public cloud, I think almost every time you'll find that the cost is outrageous and the public cloud doesn't make sense. In the public cloud, you have to rethink those workloads. You have to rethink your design implications, which means you have to take a look at this workload and say, does it really need to run 24/7? If it doesn't, when can I power it off? And if I need to power it off, what are the automation requirements that I need to put around it in order to make sure that this particular workload and all of its prerequisites are being powered off between, I don't know, the hours of 10 p.m. and 4 o'clock in the morning because, well, nobody's really using it. And then I power it back on when people are actually using it. Take the same thing for when you're scaling the application. So if it needs 5 web servers, does it need these 5 web servers all the time? Can we create some automation against spinning up and spinning down web servers when there's not a lot of load? What this will lead to is it'll force you to rethink the design of your workloads. And this is meticulous design ideas now. This is things that you have to actually sit down and think about. And this is one of the reasons why a lot of people have shied away from the cloud. They've done the calculation. The cloud is more expensive, and they've shied away from it. But if you take the time to go through it, you'll find that there's a lot of cost savings from a cloud perspective. Enterprise agreements, again, we've touched on those a little bit. So when we look at AWS reserved instances versus Azure commitment plans, there are certain things that you have to consider between all of these, right? So first, you have the ability to choose between Are you guys still there? Lindsay, can you still hear me?
Elias, you're still good. We can hear you.
Okay, cool. Sorry, I thought I got cut off there. So you need to base it on expected usage. So never try to over-provision a particular workload. Always try to base it on expected usage. Actually, you probably want to try to under-provision it and then just adjust that whenever the workload becomes increasingly difficult. And you have
You have different bands there, so you can start with low, medium, and high as far as AWS is concerned also. It offers 1 or 3 year terms with upfront fees. So you can go through and say, okay, I'm going to commit to 1 year for this particular workload. I'm going to run it on the low workload for a year. One of the things I don't recommend here is that you commit to 3 years. And the reason I say don't commit to 3 years is because if you look at what Amazon has done in the last year, they've cut costs so much, up to 42 or 45 times, that if you're already committed for 3 years and they're cutting these costs so much, well, then you're not really taking advantage of some of these cost savings. So 1 year is probably a good term to commit to, and you'll see that there are some savings when you commit to 1 year as opposed to trying to just pay as you go. Again, longer term and higher utilization are going to give you lower per hour. So the longer that you commit, the cheaper it's going to be for you. You should also allow for moving to other availability zones or regions. So make sure that you can move these workloads between availability zones or regions. It's easy to deploy. It requires, but it requires a lot more design, and there's a lot of more thought process that you have to put into it ahead of time when you're dealing with AWS reserved instances, and I'll show you that in a second here. You can also sell it on the marketplace. So that's a really cool feature that AWS reserved instances also has. If you've committed to a 3 year term, for example, on a high workload, and all of a sudden you don't need it anymore, or you're trying to get rid of it, you can chop up that high workload into smaller instances and try to sell it to someone else on Amazon's marketplace. Obviously, it has to still be price competitive, otherwise nobody would purchase it. But you have the ability of breaking down that workload into smaller chunks and then putting it on the marketplace for resale. With Azure commitment plans are a lot easier to consume and to understand. It's based on a monthly pay commission or pay per use, and I'll show you again those in a second here. You have a minimum of $500 to spend a month, so that's the minimum to get in. You also have discounts between 20 and 30 or 32% that we'll talk about and how those apply. It applies to all resources except for storage, so you can take advantage of the commitment plans for everything except storage. And it's very simple to use. You don't need a lot of upfront design criteria in order to figure out commitment plans, and I'll show you that. It's also non-refundable, of course. So what do I mean when I talk about there's a lot of design principles, a lot of design that has to go into figuring out what you're doing with this particular workload? If you try to go on Amazon and you're just consuming a service, you're putting your workloads on there, and you're essentially just paying for the usage, you'll find that you're missing out. You're paying more than what you actually can save. And I'll give you an example. You'll see here that in light green on the 1 year, 14 hours per day workload, if you're running that on the on-demand, you're paying about $3,125. If you take that for the same 1 year, 14 hours a day on the 1 year medium, and you're committing to 1 year medium, which means you're going to run it for a certain amount of time, then you'll find that it's cheaper, right? So it's costing you now $2,935. So why would you pay on demand when you can make that, if you know you're going to run it for a year, well then make that commitment, use the medium workload, and you're saving money, right? So anything 12 hours or less for a year, on demand is probably going to be a little cheaper. Anything 12 hours or more, up to 16 hours, that medium band commitment for 1 year is going to be cheaper. So if you take a look at what I have in light blue, that's also 1 year, 16 hours a day. That's what you're expecting the usage to be. If you're going to pay on demand, that's going to cost you $3,571. Obviously, for 1 year, it's going to be cheaper. But take a look at this. You can go for 1 year, 24 hours a day, and you're going to be paying $3,700. So that's a $200 difference, but you're getting almost 24 hours. You're getting 24 hours more out of that workload. So if you're using on-demand, you're paying $3,500, pay $200 more, and you're able to run that workload for 24 hours on a medium workload, and you're paying just $200 more. If you commit to the high workload, which means the application is always going to be powered on, you cannot power it off. Even if you power it off, you're still going to be charged for 24 hours. Well, then at that point, it's at $3,300. So again, you're saving more money. You can get into the 3-year bands and you can see how things start to fluctuate. Again, if you're getting into the 3-year bands, just keep in mind, if things are going to change, if Amazon cuts their prices, you're not taking advantage of that, which is why I try to shy away from the 3 years. But taking a look at this particular table, it gives you an idea of when you're designing your workloads, which workload needs to run for how long. That's when you decide whether it's going to be an on-demand, whether it's going to be a medium workload or a high workload. Again, a high workload assumes that you're running it for 24 hours. You're not going to power it off. The medium workload assumes that you can power it off, and if you power it off, you don't pay for those hours. So again, it depends on how you're designing your workloads. You can take significant advantage of it. So when customers say, well, we did the calculations and the cloud's more expensive, Amazon's not cheap. Well, did you really go through a meticulous process and evaluate your workloads, or did you just say, on demand, here's how much it's going to cost per hour, equals this much, this is too expensive, or it makes sense for the first year, but then moving forward it doesn't. If you take the same design principles that you do on premises, the cloud's going to be more expensive. If you take a new approach and you decide to investigate and spend time designing this, then you're going to find that you can save money with the cloud. The other thing that I want to mention before I move on to Amazon is that depending on where you're coming from, you can either make the cloud look very good or you can make the cloud look very bad. Everybody, Amazon, Microsoft, everyone can lie with numbers. And what I mean by that is you can make the numbers look the way you want, right? If you're coming with a presupposed idea that I need to justify the cloud is bad so I can justify my job, for example, then you can make those numbers look very bad. But if you come with an open mind and say, no, I cannot stop this, I'm actually going to embrace it and see how I can add more value to it, and you do a proper calculation, then you'll find that there's a lot of money to be saved when leveraging the cloud. Azure commitment plans, again, this is an interesting one that I've had several conversations with customers about. This is essentially based on how much you're going to be spending a month. What the important thing to know there is that, for example, in the first discount band, it's anywhere from $500 to $14,999, right? I've had customers that were sitting at like $12,500 and something a month. Well, in that case, it might make more sense if you go to the second band, which is the $15,000 to the $39,000, because you get a higher discount rate when you go there. So you compensate for that money. So you're getting more for your money, essentially, and sometimes you're paying less. And depending on how the finance organization likes to pay certain contracts, if you prepay a full year in advance, then you're getting a higher discount. If you're doing 6 months on a monthly pay, then you're getting a smaller discount, and so on and so forth. So as you take all of these into account, again, you'll find that you can bring that cost into perspective when you're looking at it this way. Understanding features. Features are going to be crucial for getting into the public cloud, especially because features are going to be what's going to make it or break it. If a particular cloud provider has the features that you want for the application that you want, then it's going to make more sense to go with them, even if sometimes they might be more expensive. So consider the free tier. They both offer free tiers, so they both offer the ability for you to try the Amazon AWS service, to try Microsoft Azure, put some workloads on there, try to understand security, try to understand load balancing, see how it works, take advantage of the free tier to kind of get your feet wet into this particular service. Naming conventions and feature parity, and this is one thing that we do very well in the course, is that we'll put them side by side and say, this is what Amazon calls DNS versus this is what Azure calls DNS. For instance, Amazon will call DNS Route 53. It's very different than what we're used to, but it's a different naming convention. So understanding the comparisons, the naming conventions, will go a long way from a feature parity perspective. Storage tiers, understanding the different storage tiers that each will offer, because sometimes you're going to need to store certain storage for backup and archiving. You want cheap storage. Conversely, you might have your application that's running on there, and you might need the fastest tier of storage. You might have your file servers, and you might need a medium tier of storage. So understanding storage tiers is important. Understanding networking, what they're both calling virtual networking, or virtual private data centers, or a virtual private cloud. So understanding the different naming conventions will go a long way. Load balancing, another one that comes to mind as well. Hosted database services. Both Azure and AWS will both offer hosted database services, whether it's SQL or relational database services. They'll both offer them. Now the question here is whether or not, for example, your application requires Windows integrated authentication. Well, does Amazon provide that with the hosted database services? Does Azure provide that with the hosted database services? If my application doesn't require that, well, then maybe that's not a problem. I can also still continue to build a Microsoft SQL Server and put it on Azure if, for example, Azure hosted database services don't support Windows integrated authentication, which, by the way, they both don't for hosted database services. So these are some of the intricacies, some of the behind-the-scenes stuff that you should be aware of. But hosted database services, also, if you're able to take advantage of it, is good because then they're handling the availability, the uptime. You don't have to worry about that. Interzone traffic. How do they charge for interzone traffic? Is there a fee when I'm trying to communicate on the Amazon Azure cloud between different subnets or different networks? Is there a fee there? Between availability zones, for instance, for AWS, is there a fee there? How does it work? What do I need to configure? How do I configure that? All of those are questions that should definitely be asked. Direct Connect, that's another very important feature to know before you make a decision on whether to go with one or the other. If I want to establish that direct MPLS connection between my environment and Azure or my environment and AWS, how many access points do they offer? How many partners do they offer? What is the cost there? Are they charging me for ingress and egress traffic? All of those have to be taken into account before you're making a decision. So you can see at this point there's a lot more than just cost per hour that goes into that decision matrix. Understanding SLAs. This is probably my favorite one. So everybody will advertise 99.900 and 99.59s, right? But when you start to peel it back, and I have that also illustrated in a table in the course, you'll start to find that different services have different SLAs. Some of them are 99.9, some of them 99.999, some of them are 99.99. So you need to understand these SLAs in order for you to hold them accountable. Now the other thing is, well, what happens in the event of an outage? Well, what happens in the event of an outage is that they will compensate you in terms of credit for the time lost, so you'll get credit back. But you can also design your environment, hopefully, around these outages and around making sure you have high availability zones. Understanding the infrastructure, and I mentioned this earlier with AWS, for instance, if you put all of your workloads in one availability zone, that's not a breach of SLA because it was a design error, not necessarily SLAs that weren't met. So understanding behind the scenes what's going on with these SLAs will go a long way. Support. So support is very important because they both will offer several tiers of support. Some of them are development focused, some of them are free tiers. So even the free tier will get some level of support, and then you have advanced levels of support that give you different capabilities and different options. Some of them will even help you to deploy a particular application. So for example, if you're trying to deploy, I don't know, Citrix Zen Desktop on AWS, well then you can, if you have the right level of support, they'll be able to help you architect this application against the infrastructure, advising you on the types of networking, how to configure your routes, what storage to use, etc. So there could be application level support. They also will offer you things like they will automatically check your environment and your applications for a health check. So if something stands out, like maybe you don't have two-factor authentication, they will be able to alert you. So understanding the different support tiers is also crucially important. And this should be number 6 instead of number 5, but understanding operations. Operations is very important. Monitoring the environment, being able to figure out how to monitor those metrics and how many metrics you get for free, how often does it query this metric, how you can do reporting against it. Billing becomes crucial. So if you know that you want to spend $1,000 a month with Amazon, and you don't have the billing alerts that basically tell you that in the first 2 weeks you've already spent $1,000, then you're going to get a big wake-up call at the end of the month because guess what? You're going to be spending a lot more than $1,000. So building these alerts through the operations frameworks that they both offer to ensure that you're getting proper alerting when you've hit certain thresholds that you've established is going to go a long way to keep costs and billing under control. You also want to take a look at do they provide mobile applications so that you're monitoring maybe these workloads on the go. How many different types of notifications can I get? Can I get SMS and email and other alerts. How does that work with my on-premises environment if I want to monitor it on my own? So a lot of these come into play as well when you're talking about operations. Security is probably the biggest one, right? So aside from authentication, and here you should always use two-factor authentication, and I gave you that example in the beginning, especially when it comes to the public cloud. Two-factor authentication is almost a default. Now, this applies even for the developers that are using those encrypted keys where they're adding them to their scripts, and those scripts are going out and they're automatically generating these workloads on Amazon or on Azure. If those don't go unchecked, those can become a security challenge in the environment. So you have to make sure that you have that under control. Delegated administration and role-based access so that people are getting access to the right stuff is important. But also one of the things to consider is how AWS will do security versus how Azure will do security. So for instance, AWS is going to do security at an object level, right? So it's going to do it on every particular object. Whereas if you take a look at Azure, Azure is still relying on login services and on the traditional Microsoft type approach where you get access to servers, but you don't necessarily get access to the granularity that you want on an object level. Now I'm sure at some point they'll get to that, but the approach there is still a lot more a Windows Server approach, whereas with AWS it's an object-based approach. I'm not saying one is better than the other, but those are some of the things that you should be aware of. From a compliance perspective, again, you should be aware of what they're offering as far as compliance, regulatory compliance. Do they have SOX? Do they have HIPAA? Do they have, if you're a government agency, do they have a particular maybe service that is specific to government agencies? What do they have? So again, taking a look at those compliance, regulatory compliance requirements will also go a long way. Number 7 is hybrid cloud capabilities, integrating with on-premises. Again, this will go a long way. So if you are an existing Microsoft shop and you already have System Center Virtual Machine Manager deployed and you're trying to extend in the cloud, and hybrid cloud capabilities is a business requirement, then obviously Azure makes more sense because you're going towards more of a single centralized pane of glass management. You don't have to worry about converting your virtual machines from one format to another, et cetera, et cetera. With AWS, it'll still support your on-premises Hyper-V environment, right? And it also has the ability to give you those conversions. So you can convert those virtual machines so they can run properly on AWS. But then it's like, are you converting it once and that's it, or are you looking to move those constantly? Do you want that single pane of glass? Again, you would have to investigate some of the operational, some of the logistical capabilities of whether or not this makes more sense, again, depending on what you're trying to accomplish. And speaking of that, I'm sure most of you have gone through the P2V, the physical to virtual conversions back in the day. So I was never a fan of those. There was always a lot of cleanup that needed to be done, and it just never worked properly. And we never really did this unless it was an application that nobody really knows how to install it anymore, and we've lost the manuals and it's barely running, so we did a P2V. So in most cases, you probably want to do a fresh install, but again, a lot of the woes and things that you've learned over the years, you would have to factor in for on-premises integration. Number 8, desktop as a service. Again, most of the large cloud service providers or the players that have an effect on desktops are available for desktop as a service. Amazon has it with Workspace. Microsoft has it with Remote App. VMware has it with Horizon Air. And Citrix is about to release it with Workspace Services. So they're all playing in that field, and in the course, we go in and we do a comparison, for example, between Amazon Workspace and Remote App and Horizon Air because we have those offering Workspace Services. We only give an overview because we don't have the specifics and the details just yet. So desktop as a service is, again, one of those workloads that can be in the cloud if it's self-contained, if it doesn't need to connect back to a database in a data center. It can work in the cloud. It's not optimal. It's not perfect yet, but there's a lot of hype around it, so we figured we'd add that in there as well. So towards the end of this, and again, I tried to summarize 3 or 4 hours worth of course material in this presentation. So towards the end, verdict, which cloud is better? So I'm going to answer by saying you have to watch my course in order to get a lot more details as far as which one is more ideal for you. And what we do in the course is we actually show you a lot of these things side by side so that you understand the differences between the two and you're making your own decisions. We're not actually There's no verdict. There's not one that's going to be better than the other. It's going to be it depends, which is I'm a consultant, so I apologize. I'm always going to give you that answer, but that's the truth. It's going to depend on the circumstances, whether you have enterprise agreements with Microsoft already, whether you're a Hyper-V customer. A lot of factors are going to come into play other than the financial factors that will make the determination for you. So with that, Lindsay, I think I'm ready for the questions. I don't know if I went over the time or not, so feel free to chime in.
Thanks, Elias. It looks like we do have a lot of questions for you, and we have about 10 minutes left. Would you like for me to read them for you?
Yeah, go for it.
Sure. So I have a question for Roger. Is there a general ROI philosophy when choosing between PaaS and, IaaS approaches? For example, is there a point when using VMs that it's cheaper than using Azure websites?
So if I understand the question correctly, is there an ROI between PaaS, PaaS, and infrastructure as a service, correct?
Correct.
Okay, yeah, that's a very good question. Again, I have to answer it depends because it's not an easy question to answer because you're right. Sometimes there is a price consideration where it's cheaper to go with a platform as a service as opposed to going with an infrastructure as a service where you're putting your virtual machines and you're building them from the ground up. Is there an ROI? There absolutely is. It's just there's a lot of factors that go into that ROI that we wouldn't have enough time to discuss here. But training and the capabilities and development capabilities and the investment that you would have to make into a platform as opposed to leveraging an infrastructure as a service and leveraging your existing knowledge, all of that is going to factor in. But the short answer is it depends. If you're starting off fresh, if you're in a brand new organization, maybe platform as a service makes more sense. If you're an existing organization, maybe infrastructure as a service makes more sense on the short term. But again, the ROI will determine whether or not short term it's better or if it's better to just kind of pull the plug and go towards a platform as a service. Platform as a service definitely is it's a wave of the future. It's definitely present, and the follow-up to this course is going to be comparing Amazon and Azure and others, hopefully, from a platform as a service. So not just from an introductory or just the infrastructure components, but also digging a little deeper into some of the developer aspects and the platform aspects. What else you got for me?
Okay. Jim asks, what about the independent consultant who just wants a small dev environment? Do they need to commit to $500 a month?
So the commitment plans is so that you can get higher discount values. If you didn't want to commit to the $500, you can just do the pay-as-you-go, or you can use if you're a consultant and you have an MSDN subscription or some of those, you can leverage those, or you can use the free tier. So, for instance, with Microsoft, you get the ability to spin up workloads up to $200 a month, I believe it was, for free. So you can leverage the free tier also for some of these workloads. So the answer is it depends, and you'll find that the free tier will play there. So I would suggest that you investigate the free tier. As far as the $500, it depends on how long you want to use those VMs. And again, that's one of the areas where one cloud provider might be a little more attractive than the other, because if one forces you to have a specific spend a month where another doesn't, and this is your driving factor, you don't care about the other features, well then that will help you make a very quick determination there.
Okay, I've got a question asking about whether or not communication is possible between different public clouds.
Yeah, absolutely. So it depends on what you're asking, though. So if you want to establish a direct MPLS connection, for example, between Azure and AWS, that might not be available today. But what I'll say is that's probably coming in a very near future, and that's coming through colo providers like Equinix and Savvis and CenturyLink and all the traditional ones, right? Where what they're doing is they're establishing these direct connections between these large cloud providers, and as a result, you can get to leverage them. Today, if you wanted to establish that connection, it would probably be in the form of a secure tunnel or a VPN where you're able to extend that or make that connection. So it's not as elegant, or it's not the way you probably are asking the question of how you think it is, but it is definitely doable from a site-to-site VPN.
Okay, it looks like we only have time for maybe one more question. So if your question was not answered, feel free to tweet your question online with hashtag PluralSiteLive, and we will be sure to record those questions. I would say our last question comes to you asking, in your opinion, what is holding back most companies from fully embracing the cloud for production workloads?
Yeah, that's a great question. So there's a lot of different factors. I think the first factor is a lot of people think that the cloud is actually going to replace them, and that's kind of job security. I think I've heard that more often than not. I think the way people should be looking at the cloud is the cloud leverages the best use cases of outsourcing without getting rid of the human capital portion of outsourcing that was traditionally the case, right? So instead of outsourcing everything, your environment, your servers, your hardware, and your people, with cloud you're able to outsource essentially your hardware, the data center, the plug and play, the rack, stack, and configure, and you're able to continue to have your human capital, your intellectual property, your employees that can configure these applications and have them focus more on the things that make sense. So if you approach the cloud from that perspective, you'll find that it's not threatening to your job. So that's one. The other thing, I think there's a lot of misconceptions as far as security in the cloud. So there's a lot of fears that the cloud is not secure. Some of those are justified. Some of those are not justified. Now, the cloud is a shared environment. So, for example, when people are complaining about security in the cloud and putting data in the cloud, well, most of them already have data on Dropbox. And the problem with putting it on Dropbox is that the underlying infrastructure of Dropbox is Amazon. So if you're able to trust Dropbox, then why aren't you considering it for the rest of the stuff? And you'll find that a lot of the data is enterprise data that's sitting on personal Dropboxes. So the security concerns are definitely valid, but I think they're a little exaggerated as far as the cloud is concerned. The third thing is storage. So a lot of organizations don't really know how to deal with storage. There's just a large amount of storage on premises today, and moving all of that storage into the cloud can be cost prohibitive. So how do you really address those large amounts of storage? So that's definitely a factor. And then communication links, right? Latency. What can I put in the cloud versus what I can't put in the cloud? Do I need to use software as a service, or am I just leveraging infrastructure as a service? How do I get all of those to kind of interconnect? I think the cloud is a little bit overwhelming, and we need to take just a step back, try to re-understand, re-familiarize ourselves with the cloud and take egos out of the picture. Be willing to say, okay, this is something new. I need to learn it, as opposed to try and apply things that you've known for years against the cloud. That will never work, and that's where I've seen a lot of organizations fail at it.